So if we take a look at this question, it says the first ionization of a halogen atom X is represented by the equation below, and here's the equation right here. And we want to know which of the following correctly describes how the first ionization energies of the halogens changes moving down the halogen column on the periodic table, and which one of these provides the best explanation. And so a couple of things from this question. First, we want to know the first ionization energy that is going to be described by the halogens, and we're moving down the periodic table. And so we have ionization energy and moving down the periodic table for the halogens. And so we need to pull up a periodic table so we can get a better idea of what's going on in this problem. And so if we pull up a periodic table, we'll get something like this. And so here's a periodic table, and where the halogens are going to be right here. We have F, Cl, Br, I, At, and Ts. These are the halogens. And what you need to know about the ionization energy is that as you move to the right and up the periodic table, the ionization energy is going to increase. And so right here for F would have a high ionization energy, and right here would have a low ionization energy. And so what an ionization energy is it's the ability to remove an electron in a gaseous state. And for a first ionization energy, it would be the energy to remove an electron in a gaseous state from a neutral atom. And so that's what ionization energy is. And there's also this other part. We have to worry about how these atoms change as we go down the periodic table. And what you need to know is, as you go down the periodic table, the size is going to increase. And so as we go down the periodic table and as we go left, the size will increase. And so this right here, this F, is very small, and this Ts right here is very large. And we also know that the ionization energy is very high right here, and it's going to be a lot lower down here. And so we need to find the answer that basically is going to explain this right here. And so let's pull up the question again. And if we look at these choices right here, B says the first ionization energy increases because the electronegativity decreases. And if we're moving down the periodic table, then the ionization energy is going to decrease. So B is going to be out because this says increase and it should say decrease. So B's out, and also C is also going to be out. So that has us with A or D as being a possible correct answer. And so if we look at these two answer choices, A says the energy of the valence shell increases. And what a valence shell is, a valence shell describes the outer electrons. And so if we think back to Coulomb's law, if we have the protons in the middle right here, and then we have electrons on the outside over here, and these electrons are going around this proton like this, there's going to be a force that's going to be felt from the protons and the electrons. And that force is described by Coulomb's law. And so these are both going to feel a force going towards each other like this. And that equation will be this. It's going to be that the force that's being felt by these two charged particles, the same force, this force here and this force here, is going to be equal to K, which is going to be a constant, and we have Q1, and Q1 can represent the protons, or it can represent the electron right here. It can be either one, and then we have Q2, so the other charge, and then we're going to have that divided by this R squared, and this R represents the distance from these protons here to these electrons over here, so this is R right here. And so if the valence shell increases, because these atoms are getting larger, it means that this R right here is going to increase. So the R is going to increase, and what happens when this increases, this force right here will decrease. So if this force here becomes smaller, it means that it's going to be easier to take an electron here and remove it. And that's what an ionization energy is. It's going to be the ability to remove this electron. And it's easier to remove electrons if the force is smaller. And so the answer choice that's going to be correct is going to be A.